Okay, so last time we have solved example number 17. Solve with me. Example number 18. Write down. Example number 18. An oil drop B has a charge 1.6 into 10 raised to minus 19 coulomb. So we are given information of oil drop. It has charge 1.6 into 10 raised to minus 19 coulomb and mass 1.6 into 10 raised to minus 14 kg. We are given information of oil drop. The oil drop is in equilibrium position, means right now net force acting on the oil drop is 0. Then what is the potential difference between the plates? Potential difference between the two plates is equal to question mark. The distance between the plates, let us take small d, 10 millimeter. Distance between the plates small d 10 millimeter, and value of g they have given as 10 meter per second square. So this is the information that they have given us. Solution. This is a plate, this is another plate. They have shown the charge on the plates wrong. Charge on the upper plate is negative and charge on the lower plate is positive. So show the upper plate negatively charged, lower plate positively charged. Between these two plates they have placed a oil drop. Oil drop has mass as well as charge. Oil drop has mass as well as charge. What is the BD of the oil drop? First force that will act on this oil drop will be own weight mg, but net force acting on the oil drop is 0. So there should be one more force acting on this oil drop. It has mass, so it will experience gravitational force. It has charge, so it will experience electric force. Now the charge on this oil drop is positive, so positive plate is going to repel the charge and negative plate is going to attract the charge. Therefore effectively there will be upward force, upward electric force. You can either say this positive plate will repel the charge and negative plate will attract the charge, so there will be upward electric force and downward gravitational force. You can say that this oil drop has charge Q. It is placed in the electric field. This positive charge creates its electric field in this region, and this negative charge also creates electric field in this region. Positive charge will create electric field away from it and negative charge will create the electric field towards it. So effectively there will be electric field like this. In this region there will be electric field upward, away from positive and towards negative. This positive charge will create electric field away from it, negative will create towards it, so effectively it will be upward. When mass is placed in the gravitational field, it experiences force mg. Similarly, when charge is placed in the electric field, it experiences force QE. Mass placed in gravitational field experiences force mg. Similarly, charge placed in electric field experiences force EQ or QE. So this is the electric force. This oil drop has mass m and charge Q. Now because it is in equilibrium, we can write EQ equal to mg. Charge on the oil drop is given to us Mass is given to us, acceleration due to gravity is given to us, and electric field can be found. But we are not asked electric field. What is asked? Potential difference between the plates. So write down. Take potential difference between these two plates as delta V. Potential difference between these two plates as delta V. And separation between these two plates, let us take it as small d. Separation between these two plates as small d. Now we know for uniform electric field, if the field is uniform, there is some relation between potential difference and distance. What was that? I think we wrote it yesterday. For uniform electric field, we wrote it here. For uniform electric field, we know what is the relation between potential difference and distance. We can write potential difference between the equipotential surfaces upon the perpendicular distance between the surfaces, only for uniform electric field. So we will assume that in this region electric field is uniform, means at all points it is same in magnitude and direction. At all points it is same in magnitude and direction. वाजवू नकोस किती, तुला होते का शांत बसायचं? At all points we will assume that electric field is same in magnitude and direction. Clearly direction is upward and magnitude is E, let's say at all points. Then this electric field can be replaced as potential difference between the two surfaces, between the two equipotential surfaces upon perpendicular distance between those two surfaces. It is D. So delta V upon D is equal to what? mg. Now clearly separation is known, charge is known, mass is known, g is known. Find out delta V. Write down mgd answer will be mgd upon q. Now put the values and get the answer. Mass is 1.6 into 10 raised to minus 14. Value of g is 10. Separation d is 10 millimeter. So whenever you do replacement, put the bracket. See, I am doing replacements, putting bracket. Charge is 1.6 into 10 raised to minus 19. 1.6 cancel. Minus 14 minus 19 plus 5 plus 5 plus 6 plus 7 plus 7 minus 3 plus 4. So 10 raised to 4 volt or 10,000 volt is the potential difference between the two plates. So this is our answer of electric potential difference between the two plates. Clear? Solve next example with me. Example number 19. Some equipotential surfaces are shown in the figure. What is the correct order of electric field intensity? Question number 19. What is asked? Correct order of equipotential surfaces. Correct order of, not equipotential surfaces, correct order of electric field. So draw the equipotential surfaces. They have shown equipotential surfaces like this. Here they have shown the point A. Here they have shown point C. And somewhere here they have shown the point B. These are not electric field lines. These are equipotential surfaces. These are equipotential surfaces. These are not electric field lines. These are equipotential surfaces. You can remember a rule. This rule is similar to electric field lines. If electric field lines are crowded, then in that region electric field is more. If the electric field lines are not crowded, then the electric field is less. Similar to, write down, if equipotential surfaces are crowded, then electric field in that region is more. The electric field in that region is more. So where is the highest density of equipotential surfaces? Where are they most crowded? At B. So at B electric field will be highest. And where are they least crowded? Now this A region separation is between the two surfaces. A region separation is very high compared to C. So A will be least. So in between you will have C. Now if you want to find direction of electric field at point A, you know direction of electric field should be perpendicular to equipotential surface. So it should be like this, perpendicular to equipotential surface. At point C it will be like this, perpendicular to equipotential surface. At point B it should be like this, perpendicular to equipotential surface. Draw it. You should be able to figure out the direction also. Of course direction cannot be compared. We are comparing here magnitudes of the electric field. Clear? Next point. Next heading, write down with me. Electric dipole. Next heading is electric dipole. Let me read. A system of two equal and opposite charges separated by the small distance is called electric dipole. Underline in the module. The system of two equal and opposite charges separated by the small distance is called as electric dipole. So let us draw the electric dipole. Draw with me. System of equal and opposite charges means minus q plus q separated by the small distance is called as electric dipole as shown in the figure. Underline. Every dipole has characteristic property called as dipole moment. Underline. Every dipole has characteristic property called dipole moment. It is defined as product of magnitude of either charge and the separation between the charges. Underline. It is defined as product of magnitude of either charges and separation between them. Underline. Dipole moment is a vector quantity and conventionally its direction is given from negative pole to positive pole. Direction of dipole moment is taken from negative pole to positive pole. Okay, so draw with me. All these points are important. Underline entire paragraph. So draw with me. This is negative charge. This is equal but positive charge. Let us say this is the center of the dipole. Let's say distance between negative charge and center is small l. Positive charge and center is also small l. Then total length of the dipole or separation between the charges can be written as 2l. Total length of the dipole is 2l. First charge is minus q, second charge is plus q. These are equal and opposite charges separated by small distance. Okay. Now let us define a new physical quantity called as electric dipole moment. New physical quantity called as electric dipole moment. Its magnitude is given as product of one of the charges and separation between them. So we have two charges plus q and minus q. Write any one charge, magnitude of any one charge multiplied by separation between them. Separation between them is 2 times L. 2L is the length of dipole or separation between charges, and small l is half length of the dipole. Small l is half length of the dipole, 2L is total length of the dipole. This is a vector quantity. Its magnitude is q into 2L, and by convention its direction is from negative charge to positive charge. Write down. Direction is from negative to positive charge. Its direction is from negative charge to positive charge. So let us show an electric dipole moment vector like this. This is our electric dipole moment vector, or you can simply say dipole moment. Dipole moment or electric dipole moment, P bar. Its magnitude is q into 2L and its direction is from negative to positive charge. Its direction is from negative to positive charge. So every dipole has associated dipole moment, and dipole moment has formula q into 2L. Now you tell me what is unit of electric dipole moment. It is unit of charge into unit of separation. What is unit of charge? Tell me. Coulomb. What is unit of separation? Meter. Now don't write here small c. If you write here small c, you will read it as centimeter. It is not centimeter, it is coulomb meter. So c must be positive. So this is the unit of electric dipole moment. Now let us find dimensions of electric dipole moment. How to find dimensions of electric dipole moment? First convert it into fundamental unit. So what is unit of dipole moment? Coulomb is not fundamental, so Coulomb can be replaced as ampere second. Correct. Coulomb can be replaced as ampere second. Charge equal to current into time. Meter as it is. So you can write this as kg raised to 0, meter raised to 1, second raised to 1, ampere raised to 1. So this is unit of dipole moment in terms of fundamental units. So what are the dimensions? Kg means mass raised to 0, meter means length raised to 1, second means time raised to 1, and ampere means current I raised to 1. So now we have unit as well as dimension of electric dipole moment. It is a vector quantity. Its direction is from negative charge to positive charge, and its magnitude is defined as product of one of the charges. We have two charges. Out of that, any one charge and separation between them. Product of magnitude of one of the charges and the separation between the two charges. Q into 2L is the formula for electric dipole moment. Any doubt in this? Next point, write down with me. Electric field due to the dipole. Electric field due to dipole. Electric field due to dipole. Dipole has two charges, plus Q and minus Q. Both of them will produce the electric field, and we have to find net field. So electric field due to dipole, sub point is at a point on the axis of the dipole. At a point on the axis of the dipole. So draw with me. Always while drawing the diagram, leave some space above the diagram where you start. Also leave some space on the left side, right side also. So always try to draw diagram in the middle. So let us say this is minus Q. Let us say this is plus Q. Let us say this is center of the dipole. Let us say this is half length L of the dipole. This is remaining half length L. Total length will be 2L. The line passing through both the charges is called as axis of the dipole. So we will take this line as axis of the dipole. So write this name of this line. This is axis of the dipole, line passing through both the charges. Now take any general point on the axis of the dipole. Call that any general point as Z. Call that any general point as Z. At point Z, we want to find out net electric field produced by this dipole. Dipole has two charges, plus Q and minus Q. Plus Q will produce electric field at point Z, away from it. So let's say this is the electric field produced by the plus Q. So let us call it as E plus. E plus means electric field produced by positive charge. At the same point, this negative charge will also produce the electric field. How much? E minus. And in which direction? Towards. This negative charge will produce the electric field. Away from it or towards it? Towards it. This E plus and E minus are just numbers. The arrows take care of directions. This E plus and E minus are just magnitudes. These arrows take care of direction. Which electric field will win? These two magnitudes are these two vectors are opposite to each other. So to get the resultant magnitude, we have to subtract them. But before that, we should know who will win. E plus will win or E minus will win? E plus will win, because both the charges are equal. But E plus will be more because positive charge is closer, and this negative charge is comparatively further or away, comparatively at larger distance from point Z. Okay, remember that all the distances are generally measured from the center of the dipole. So this minus Q is at distance L. This plus Q is also at distance L. This any general point, let us take it at distance equal to R from the center of the dipole. Let us take this distance of any general point from the center of the dipole as R. Now you tell me, what is this distance between plus Q and Z? Correct, it will be R minus L. And what is distance between minus Q and Z? What will be the distance between minus q and z? R plus L. Now, this E plus and E minus, who will win? E plus will win. So net electric field will be away or in the direction of E plus. This is called as net electric field at a point on the axis, E axis. To find electric field at a point on the axis, we have to subtract these two magnitudes. If vectors are in same direction, add the magnitudes. If vectors are opposite in direction, subtract their magnitudes. If vectors are perpendicular, use Pythagoras theorem to find the resultant magnitude. And if vectors are at any general angle, then you can use parallelogram law. Now we have to find electric field at a point on the axis of the dipole. So for that we need this E plus and E minus. Now you tell me, what is the value of E plus? Electric field produced by the positive charge. This is point charge. So use the formula of point charge. It is kq by r square. K is k, q is q. What is r? What is r value here? R minus L. Write down. kq by r square. And what about E minus? Magnitude of electric field produced by the negative charge. How much electric field will be produced by negative charge? kq upon r square. K is k, q is plus q or minus q. We are finding magnitude. We are not finding electric potential. If you want to find electric potential, charge must be substituted with sign. Here you are finding electric field vector, no, electric field magnitude. So what will be E minus? kq by r square. K is k, q is not minus q, q is still plus q upon r square. What is this distance? R plus L. So R is R plus L bracket square. Now we know E plus and E minus. So what will be the net electric field at a point on the axis? What will be net electric field at a point on the axis of the dipole? E plus minus E minus. Electric field by the positive charge minus electric field produced by negative charge. So put the values, write down. kq upon r minus L bracket square minus kq upon r plus L bracket square. What can be done? kq can be taken common. In the bracket, do the cross multiplication. R plus L bracket square minus R minus L bracket square. Write down. लिहिते. Hello. Upon multiply this R minus L bracket square into R plus L bracket square. Now A plus B bracket square minus A minus B bracket square. What will be the square of this? R square plus L square plus 2RL. And what will be the square of this? R square plus L square minus 2RL. Because of this minus sign, R square cancel and L square cancel. What will remain? 2RL will remain in the first bracket and in the second bracket minus 2RL. Now this bracket can be taken as A and this bracket can be taken as B. A square into B square is AB bracket square. So combine these two brackets. R minus L into R plus L whole bracket square. Huh. 2RL minus 2RL is 4RL. Now treat this R minus L and R plus L as A minus B into A plus B. So A minus B into A plus B is what? A square minus B square. Okay, this whole bracket square is also there. Don't miss that. This is A minus B and A plus B, which is A square minus B square, but this whole bracket square is also there. So this is actually the final answer, but people modify this answer. Can I rewrite this as K, Q, this 4RL, can I write that 4RL as 2L into 2R? 4RL, can I write that 4RL as 2L into 2R? This is 4RL upon this R square minus L square whole bracket square as it is. I will put the bracket here. What is this Q into 2L? Dipole moment. What is Q into 2L? Dipole moment. So what is the formula for electric field at a point on the axis of the dipole? K P, dipole moment, Q into 2L is P, 2R upon R square minus L square bracket square. You can rearrange it as K means 1 upon 4 pi epsilon 0, 2 PR upon R square minus L square bracket square. This is the formula for electric field at a point on the axis of the dipole. This is the formula for electric field at a point on the axis of the dipole. K 2PR upon R square minus L square clear? Now you can write the vector form of this equation also. What is the vector form of this equation? What will be the vector form of this equation? Vector form means on the left side as well as on the right side there should be the vectors. So for that, check the direction of electric field at a point on the axis and check the direction of dipole moment. Okay, what is direction of dipole moment? Let us draw the dipole moment vector. What is direction of dipole moment? Negative to positive. So this is our dipole moment vector. Draw it. This is our dipole moment vector P bar. It is from negative to positive. So direction of dipole moment and direction of axial electric field, they are same. Direction of electric field and direction of dipole moment are same. So you can convert this electric field into vector E bar and you can write this dipole moment into vector as P bar and write the vector form. So I don't have the space, so I will write us write the vector form here. This is the final answer, final step, but we are doing it here. Electric field at a point on the axis of the dipole E bar is equal to. Now we are writing vector on the left hand side. So K 2 P bar into R upon R square minus L square bracket square. This is our vector form. P bar and E bar both are in same direction. You can check. Axial electric field is also from negative to positive, and P bar is also from negative to positive. So both of them are in same direction. So write down this as vector form. हा झाला तुमचा वेक्टर फॉर्म. ठीक आहे, असू दे तसं असू दे. दिस इज अवर वेक्टर फॉर्म. क्लियर? Any doubt in this? How to find electric field at a point on axis? Field due to positive charge plus field due to negative charge. Then both the fields are opposing each other, so subtract them to get the final field, to get the net field. Second bit B. At a point on the equator, electric field due to dipole at a point on not axis but on equator of the dipole. Now leave some space here above the dipole. Let's say this is minus Q. Draw with me. This is plus Q. This is center of the dipole. This is half length L of the dipole. This is remaining half length L of the dipole. So total length will be 2L. This is the dipole moment, negative to positive, P bar. This is dipole moment, negative to positive, P bar. Now this line which is passing through center and perpendicular to axis, this line which is passing through center and perpendicular to axis, axis means line passing through both the charges. Line passing through center and perpendicular to axis is called as equator. So write the name of this line. This line is called as equator, not equation. It is equator. This line is called as equator. So choose a point on the equator. Let us choose here. Let us choose the point here. Yes, here charge is positive. This is positive charge. This one is negative. Let us choose any general point. Let us call that any general point as Z at a point on the equator. We know all the distances are measured from the center of the dipole. So let us take distance of point Z from the center of dipole as small r. Distance of point Z from the center of the dipole as small r. Now this positive charge will produce its electric field at point Z. This positive charge will produce its electric field at point Z. In which direction? Away or towards? Positive charge will produce its electric field away, like this. Similarly, the negative charge will produce its electric field at point Z. In which direction? Towards. Negative charge will also produce its electric field at point Z. So let us call this as E plus and let us call this as E minus. Now these two vectors are not in same direction, not in opposite direction, they are not even perpendicular. We don't know what is this angle between them. So how to find resultant of these two electric fields? For that we will do this thing. We have drawn the vectors. Now we will choose the axis. Then we will resolve the vectors. Then we will find resultant vector in x and resultant vector in y. And then we will find the net vector, or sorry, net magnitude by using Pythagoras theorem. So these are the two vectors, two electric fields produced at point Z. We will choose one axis horizontal, one axis vertical, and we will resolve these vectors. We will check what is net value in x direction, net value in y direction, and then we will use Pythagoras theorem. Let us assume this angle as theta. Let us assume this angle as theta. If this angle is theta, this z angle is also theta. Similarly, this is an isosceles triangle. Let us take this side length as small d. What will be this side length? Small d. This side, both of these sides are equal. Small d, small d. So if this angle is theta, this angle will also be theta. Both these angles are theta and theta. If this angle is theta, then corresponding angle will also be theta. This line and this line are parallel to each other. These two lines, this horizontal line and this horizontal line, are parallel to each other, and this is a single line. So these are the corresponding angles. They must be equal. Now you can clearly see what is happening at point Z. Redraw the diagram. Now we don't have any space here, so redraw the situation at point Z. So at point Z we have this situation. We have this E plus and we have this E minus. This is E plus and this is E minus. This angle is theta, this angle is also theta. Resolve this E plus and E minus. This will be E plus cos theta. This will be E minus cos theta. This will be E plus sin theta. And this will be E minus sin theta. Now we have resolved this E plus and E minus. या E plus ला आणि E minus ला काय करा, resolve करून घ्या. Now calculate value of E plus and E minus. Magnitude of E plus will be equal to how much? Electric field produced by the positive charge will be equal to how much? Kq by r square. K is K, Q is Q, R is what? R is what? R is D. So R square is D square. How to replace D square? How to replace D square? D will not be given to you. Only R and L will be given to you. So D square can be replaced by under root m D square है ना? R square plus L square. And what about E minus? What is magnitude of electric field produced by this minus charge? How much electric field this minus charge will produce? Kq by R square. K is K. Don't write Q as minus Q. You are finding magnitude of electric field. Kq by R square. Here also R square is D square. And again D square can be replaced by R square plus L square. Now tell me what happens at point Z. Because this E plus and E minus are exactly same, can I say magnitude of E plus is exactly equal to magnitude of E minus? Field produced by the positive charge is exactly equal to field produced by the negative charge. So this E plus and E minus are exactly equal in magnitude. Then can I say E plus sign component and E minus sign component will cancel each other? This E plus sign component and E minus sign component will cancel each other. So what will be the net electric field at point Z? This E plus and E minus cos components will get added, but E plus is exactly equal to E minus. So the net electric field at point Z is basically what? 2 times E plus cos theta. Just double any one of them. Don't exactly same है. So this is your net electric field at a point on the equator. So net electric field दाखवा इथं. This is what? Net electric field at a point on the equator. So at point Z, you will have this as a net electric field. That's it. We are at almost final answer. Net electric field at a point on equator is equal to 2 times E plus cos theta. 2 is 2. What is E plus? K Q upon R square plus L square. What is cos theta? What is cos theta? Adjacent L upon hypotenuse D. D can be replaced by under root R square plus L square. What is this? Q into 2 into L. What is this? Q into 2 into L. Dipole moment. This K as it is. Q into 2L is dipole moment P. Now consider this bracket R square plus L square bracket raised to 1 and R square plus L square bracket raised to half. This is of the format of x into root x. What is the answer of x into root x? X raised to 3 by 2. So this R square plus L square bracket raised to 1 and R square plus L square bracket raised to half means what? R square plus L square bracket raised to what? 3 by 2. So this is the formula for electric field at a point on the equator. Magnitude of electric field at a point on the equator of the dipole. 2 नहीं है ना? Kp upon R square plus L square bracket raised to 3 by 2. This Q into 2 into L is directly P. What is the vector form? Arrange vectors on both the sides. For vector form, observe here. Resultant of this E plus and E minus. Resultant of this E plus and E minus is leftward. Means it is from positive to negative. But our dipole moment is from negative to positive. Check these two vectors. Net field at equator and our dipole moment, they are in same direction or opposite? Opposite. So you can write it as minus K into P bar. Use a minus sign in between. E bar and P bar have same directions or opposite? Opposite. So when you reverse, this minus sign says reverse the direction of P bar. Minus means reverse. Reverse the direction of P bar, then you will get direction of E bar. You cannot write directly E bar and P bar. They don't have same directions. So use one minus sign to reverse the direction of P bar. Now you can get direction of E bar. So minus K P bar upon R square plus L square bracket raised to what? 3 by 2. R square plus L square bracket raised to 3 by 2. This is your vector form. This is your vector form. Is it clear? Any doubt in this? Now let us learn a special type of dipole. Let us learn new point, a special type of dipole which is called as a short dipole. Write down the heading as short dipole. So suppose this is a dipole, minus q plus q. Let us take length of the dipole as 2l. Let us take length of the dipole as 2l. Let us take this as any general point z. This is center of the dipole. See, draw with me. This is what? Distance of given point from the center of the dipole. All the distances are measured from the center of the dipole. So, if the distance of given point from the center of the dipole is very large, if the distance of given point from the center of the dipole is very large compared with the length of the dipole, then the dipole is called as short dipole. Means this minus q plus q distance should be very small. Then the dipole is called short dipole. Write down. Then the dipole is called short dipole. Now let us find electric field due to short dipole. Let us find. Next heading. Electric field due to short dipole. Electric field due to short dipole. First bit, at a point on axis. First point is at a point on axis. So draw with me. Let us say this is minus q. Let us say this is plus q. Let us say this is the axis of the dipole. Let us say this is any general point z on the axis of the dipole. Let us say this is point C, center of the dipole. Let us take half length of the dipole as L, remaining half length also as L. At a point on the axis, what is the direction of the axial electric field? First, draw the dipole moment. Dipole moment vector p bar is directed from negative to positive, and we know field on the axis. If you want to find field at a point on the axis, then its direction should be in the same direction of the dipole moment. Dipole moment is from negative to positive. Axial field is also from negative to positive. So electric field at a point on the axis and the dipole moment are in same direction. You also know the formula. You give me the formula. What is the formula for electric field at a point on the axis of the dipole? Long dipole चा formula काय होता सांगा? Long dipole K 2pr upon r square minus l square bracket square. K 2pr upon r square minus l square bracket square. But here we have short dipole. Here we have short dipole. For short dipole, see, this is the distance of given point from the center of the dipole. All the distances are measured from center of the dipole. Distance of given point from the center of the dipole is taken as small r. Here small r is very large compared with length of the dipole. Here small r is very large compared with length of the dipole. Can I say it means small r is very large than L also? If it is very large than 2L, it means it is very large than L. It means r square is very large than l square. If r is very large than l, then r square will be very large than l square. Means r square minus l square can be approximately taken as, it can be approximately taken as r square. Yes or no? Approximately it is r square. Therefore, what is the formula for electric field at a point on the axis due to short dipole? Approximate formula. See the symbol of approximation. K 2pr upon, what is this? R square minus l square, r square, and r square square is r raised to 4. So what is the final answer? K 2pr, okay, r and r square cancel, r and r raised to 4 cancel. So what is the final formula for electric field at a point on axis of short dipole? At a point on axis of short dipole, what will be the final formula? K 2p upon r cube. This is the formula for electric field at a point on the axis of short dipole. K 2p by r cube. K 2p by r cube. Write down the homework. Resolve. Solved example 1 to 19. Which chapter? Electric potential. And make list of formulae. सेपरेट पेजेस वरती करायचं, मिडल पेज सेपरेट करायचं आणि एक लिस्ट ऑफ फॉर्म्युले तयार करायची आहे. कुठल्या चॅप्टरची? याच्या मागच्या चॅप्टरची. तेच आहे ना चॅप्टर. कुठला चॅप्टर आहे? इलेक्ट्रिक फील्ड, इलेक्ट्रिक चार्जेस अँड फील्ड. त्याला आपण इलेक्ट्रिक फील्ड म्हणू. मेक लिस्ट ऑफ फॉर्म्युले ऑफ चॅप्टर. कुठला चॅप्टर? इलेक्ट्रिक फील्ड. काय होमवर्क काय कळलाय का? इलेक्ट्रिक पोटेन्शियलचे सगळे सॉल्व्ड एक्झाम्पल्स करायचे, 19 सॉल्व्ड एक्झाम्पल्स, आणि इलेक्ट्रिक फील्डची लिस्ट ऑफ फॉर्म्युले बनवायचे. हे सगळं आजच्या आज कंप्लीट व्हायला पाहिजे. आज लास्ट पेपर आहे ना. उद्यापासून तुम्हाला रेग्युलर होमवर्क म्हणजे सॉल्व्ड एक्झाम्पल डेलीचे जे काय 3-4 सॉल्व्ड एक्झाम्पल होतात ते, प्लस क्वेश्चन सेट, प्लस PYQ, प्लस HCV आणि प्लस एक्स्ट्रा क्वेश्चन, असे 5 डिफरंट टास्क मिळणार आहेत. त्यातले जेवढे ज्यांना करता येतील तेवढे त्यांनी करा. ठीक आहे? कळलंय का आजचं सगळं? येऊन घेतलंय का? थांबूया.